Evaluating information loss in digital image compression techniques, and this paper is by Shehan, Fernando and Ravindra, Wijesiriwardana. It's going to be presented by Shehan Fernando. Mr. Shehan Fernando is a lecturer in this university. His research interests are on control theory, computer vision and mathematical optimization. So over to you, Shehan, to talk about evaluating information loss in digital image compression techniques. I think it's a very important topic, so we'll be very happy to listen to you.
Good morning, everyone. Today my topic is evaluating information loss in digital image compression techniques, and my presentation is the contents of my presentation. We have what is basically the image compression, then why we need compression, then the basic image compression model, and the image compression techniques we are going to analyze in this project: the JPEG, the wavelet-based methods, and the seam carving. And finally, I'm going to demonstrate, show you the results we have obtained. So basically, what is image compression? The simple answer to image compression is just to reduce the amount of data required to represent a certain digital image. Now, if you consider the uncompressed media, like for in general audios, videos, or images, there have been lot of data capacity it uses, and when you transmit that data, it consumes a lot of bandwidth. Now, despite the rapid development of certain technologies like the mass storage density methods, then the processor technologies, and digital communication technologies, there have been a demand, still there is a demand for high data storages and for transmission bandwidth which outperform the existing multimedia technologies. Now, when you see during the past about 3 or 4 decades, there have been a significant research being done in data encoding and image compression techniques or data compression techniques, and therefore these data compression techniques becomes more and more significant in reducing the data redundancies and thereby to save more hardware storage and to save more bandwidth. Now, basically, there are two different categories of image compression techniques. First, we have the lossless and the lossy image compression techniques. In lossless, this basically preserves the information in the original data. So when you compress or when you reconstruct by decompressing, there will be no loss in the amount of information between these two. Now, for example, these kind of techniques we are using in medical imaging, then satellite imagery, and the images that related to military. But the problem is you can't go for very high compression ratios. But in lossy compression, there have been a loss of information, but on the other hand, you can go for very high compression ratios. Then here is the image compression model. So you have an encoder and decoder. This is a generic model. So fxy represents the image, and that image will be transformed into another domain using the mapper. After that, using a quantizer, we quantize the coefficient values, and after that these coefficient values are encoded using a encoding algorithm, and after that you can transfer it to data communication channel or some storage device. After that, when you want to decode, the inverse of the process will be carried out. So there we have the symbol decoder, then dequantizer, and after that you have the inverse mapper, and you get an estimate of your previous or original image. So I will brief on the basic techniques we have used. So first is the JPEG, or Joint Photographic Experts Group. So what it does is basically it divides the image into 8 by 8 blocks, and for each of these blocks it performs the forward discrete cosine transform. So in our model, previous encoding model, the mapper, this forward discrete cosine transform represents the mapper, and after that you get the coefficients, then they are quantized and encoded to have a compressed image. So the reverse process will be carried out if you want to reconstruct the original or reconstruct the image. Then after that we have the wavelet based methods. So in our mapper, this represents the discrete wavelet transform, and in the previous case in JPEG it performs on each and every 8 by 8 blocks, but here the discrete wavelet transform is carried out on the whole image. And after that we have the transformed image, we have the set of wavelet coefficients, then the quantization and the encoding will be carried out. To reconstruct the image, then as JPEG, the reverse process will be carried out. Now in this project we are testing on 3 different wavelets. The most simple one, the Haar wavelet, then Meyer wavelet, and the Coiflet 2 wavelet. And as a standard, we are only restricted to decompose the image into 2 layers or 2 levels of decomposition. You can go on for number of levels, but for testing we have only limited to 2 levels. Then we have the seam carving. It's a technique target on image compression based on detecting seams, and these seams are calculated based on an energy function of the image. So by detecting the minimum energy seams, we can remove those minimum energy seams and compress the original image. So this is the basic steps for seam carving. First we have the image map. It can be calculated by the magnitude of gradients, or you can use entropy image or histogram of the gradients. Then the cumulated energy function will be carried out by using the dynamic programming method, and after that we find from the cumulated energy map we calculate the minimum energy seams. So these are the results we have. This is the test image we used to evaluate the algorithms, and we have done four compression layers: 95%, 90%, 75%, and 50%. So 95% means only 5% of the original data will be remain. right? So this is the JPEG algorithm. So after 95% of compression, you can see the quality is very much lowered. And this is the 90% and the 75% compression, and later the 50% compression. So our objective is to analyze the information, amount of information remained in the compressed images. So this is the comparison of different levels. So we have the 50%, the entropy is remained at 5.9, then 75, and up to at 95% compression, there is a remaining of just 3.7 entropy value. Later, using wavelets. Now, as I told you earlier, I have used the Ha, Maya, and Coiflet 2 wavelets, and a 2-level decomposition will be performed. So this is the results we obtained for Ha wavelets. First, the 95% compression, 90, 75, and 50. Now, compared to JPEG, we find there is some, the quality has been improved in the wavelets. This is the most basic wavelet, though we have a very good quality in comparison to the JPEG. So this is the levels of entropies. Now at 95% compression in the JPEG we have only 3.7, but here you have more information. At 95% it's 6.2, and later you have the, when using Maya wavelet, this is the levels of entropies. So at 95% there is a 6.25, but at 50% you have a 6.35 entropy value. But if you compare with Ha wavelet,
you are running out of time, so you have about 1 minute
right.
more.
Now this is the Coiflet 2, and this is the entropy values, and this is seam carving, and we have a much higher information level for this algorithm in comparison to wavelets and JPEG. Thank you, sir.
Finishing time. Any questions? So let's quickly have some questions before moving on to the next one. Okay, so let me ask. So what you are saying is what was the last one you talked about? The seam carving. How did it differ from the other two, the technique itself?
Now in other two, this wavelets and JPEG, we are using this either JPEG coefficient, so wavelet coefficient.
Yeah, basically you are transforming it into some other domain.
From one state to another.
Right.
Now this is, we remove the minimum energy seams from the original image.
So when you say seams, what does that mean?
Seams means we calculate the minimum energy pixels in the image, and we remove that minimum energy parts from the image.
So minimum energy means compare with the surrounding pixels.
Yes.
Okay. I would like to have some of the students ask questions. Why are you here if you don't ask questions? Or you have seen him before, so you don't, not a big difference, right? We'll at least ask questions from the outside people then. Okay, thank you.